sp3 hybridization. Methane, ammonia, water, all three molecules formed by sp3 hybridization. Methane, the bond angle is 109 degree 28 minutes tetrahedral shape. Ammonia 107 degree pyramidal shape. Water molecule 104 degree 104.5 degree its bend shape. Even though they formed by all three molecules formed by sp3 hybridization, they possess different geometry due to the bond pair lone pair repulsion. Here there is no lone pair in the case of methane molecule, only bonded pair of electron, the tetrahedral shape, this bond angle. But in the case of ammonia, one lone pair of electron on its head, here giving pyramidal shape like this. In water molecule, there are two sets of lone pair of electron giving a bend shape like this. Now we are going to see the geometry formation of these three different molecules. sp3 hybridization. One s orbital of the subshell of an atom, 3p orbital of subshell of an atom hybridize together forming the sp3 hybrid orbital of equivalent energy called sp3 hybridization. Each sp3 hybrid orbital has 25% s character and 75% p character. To minimize the repulsion interaction, they tend to lay as far apart from each other. sp3 hybrid orbital has 25% s character and 75% p character. To minimize repulsion interaction, they tend to lay as far apart. Formation of methane. In methane, the carbon electronic configuration, ground state electronic configuration is 1s2, 2s2, 2p2. The valential configuration 2s2, 2p2. On excitation, in the excited state, the 2s electron absorbs energy and it becomes unpaired, forming a configuration of 2s1, 2px1, py1, pz1. So this is the excited state electronic configuration of carbon. Here one s orbital and 3p orbital involved in hybridization called sp3 hybridization. The mixing up of orbitals with approximately equal energy forming new orbital with the same energy called sp3 hybrid orbital. Here the sp3 hybrid orbital of carbon directed towards the corners of regular tetrahedron called sp3 hybrid orbital of carbon. Here the each lobe, the sp3 hybrid orbital of carbon, each lobe contains one electron. It head-on overlap with the half-filled configuration, the one electron of hydrogen forming 4 carbon hydrogen sigma bond. Here the all lone pair of electrons involved in the bond formation sharing up of electron with hydrogen atom forming covalent bonding. Here all electrons involved in bonding, the bonded pair of electron making a bond angle of 109 degree 28 minutes. So in methane, the 4 sp3 hybrid orbital overlaps with the 1s orbital of hydrogen forming methane. Here the carbon and hydrogen shares electron forming covalent bonding. The bonded pair of electron making a bond angle of 109 degree 28 minutes. It is tetrahedral in shape. Formation of ammonia. In ammonia, nitrogen is in sp3 hybrid state. The sp3 orbitals used for sp3s sigma bonds with hydrogen atom. So in ammonia, here the central nitrogen atom here with 3 hydrogen, it shares electron forming ammonia. Here the nitrogen is in sp3 hybrid state, 4 loops, but only 3 sp3 hybrid orbital involved in bond formation. Here one lone pair of electron is present on nitrogen which is not involved in bond formation. And here give the molecule shape, pyramidal structure of bond angle of 107 degree. Now we are going to see the geometry and bond nature hybridization in ammonia. Ammonia NH3, the electronic configuration is 1s2, 2s2, 2p3. Here the 2s orbital and p3 orbital overlaps, forming sp3 hybridized orbital. Here nitrogen atom has 3 unpaired electron. The excitation of electron is not possible here as it does not contain any d orbital, any d subshell. Because of the absence of d subshell, nitrogen doesn't form NH5 and NCl5. NH5, NCl5 is not available because the unpairing, the transfer of electron from the 2s orbital to outer d orbital is not possible. Here in the case of ammonia, 3 sigma bonds are present. 3 sigma bonds are present. Here the sp3 orbital with 1s orbital of hydrogen, it forms 3 sigma bonds. The nitrogen atom contracts and bond angle of, actually according to sp3 hybridization, the bond angle should be 109 degree 28 minutes, but it is contract to the bond angle of 106 degree 51 minutes, that is called 107 degree. So nitrogen atom is sp3 hybridized, pyramidal geometry and tetrahedral nature. Here the lone pair of electron is present on the head of the nitrogen. The lone pair and bonded pair repulsion, the repulsion between the bonded pair of electron of 3 hydrogen and the lone pair of electron making a bond angle of 107 degree and pyramidal shape. Here the nitrogen shares electron with the 1s orbital of hydrogen NH3. Here the lone pair of electron on its head. This lone pair of electron only responsible for the basicity of nitrogen, in ammonia also. So even though the nitrogen atom is in sp3 hybrid state, as because of the presence of the one lone pair of electron on its head, the geometry of the molecule changes, the bond angle changes. All 3 sp3 orbital not involved in bonding, only 3 orbital only involved in bonding. Thereby the bond angle geometry changes. Next one is the geometry and the shape of water molecule. Here the water molecule, oxygen is present. Here the oxygen, the atomic number is 8, the electronic configuration is 1s2, 2s2, 2p4. This is the ground state electronic configuration of oxygen atom. The hybridized state is, here 2 lone pair of electron is present in the hybridized state and after sp3 hybridization. This 2 lone pair of electron, here 2 hydrogen overlaps, pair up, forming water molecule. Because of the presence of 2 lone pair of electron and 2 lone pair of electron and 2 bond pair of electron, that is sp3s sigma overlap between the hydrogen, the repulsion between this bonded pair of electron and lone pair of electron distorted in bond angle to 104.5 degree, giving bent shape structure because of the, here the oxygen atom and 2 hydrogen atom. In water molecule, this oxygen shares electron with the 2 hydrogen atom making covalent bonding, but 2 sets of unpaired electron is present in the head of oxygen which is not involved in bonding. The repulsion between these two sets of lone pair of electron and bond pair of electron, the bond angle is distorted. Actually, like that of methane, oxygen also sp3 undergoes sp3 hybridization. The 4 sp3 hybrid orbital is present, but it only shares electron with 2 hydrogen, leaving 2 sp3 orbital unpaired, that is not involved in bonding, lone pair of electron. So because of the, according to the VSEPR theory, because of the repulsion between the bonded pair electron, lone pair of electron, the bond angle changes, distorted bond angle, here giving the bent shape to the water molecule. So methane, ammonia, water, because of the repulsion between lone pair and bonded pair of electron, the methane molecule, the geometry get changes.